Hello, this is Dr. Hanaa Assil, and this is paper 1C, June 2021. So let us take a look at the questions and discuss the answers. So the first question says the box shows the names of some substances. Complete the table by choosing a substance from the box. Each substance may be used once, more than once, or not at all. So, a good conductor of electricity. Which of these would be a good conductor of electricity? You should realize that it should be a metal, and the metal here is copper. An element that has a basic oxide. Which one forms basic oxide? You should realize basic oxides are oxides of metal. So, copper also would form a basic oxide. A substance used as a fuel? Well, you should know that methane is the main constituent of natural gas and it is used as a fuel. A major cause of acid rain. Which of these causes acid rain? Sulfur dioxide. A non-metallic element that is a solid. So which of these is a non-metal and a solid? Of course, that is iodine. You should realize that the non-metals here are bromine. Bromine is a liquid, nitrogen is a gas, and iodine, which is a solid. Describe a test for carbon dioxide. What was the test for carbon dioxide gas? Bubble the gas through lime water, it turns milky. Table 1 gives some information about 3 subatomic particles. Again, I'm going to remind you that the word subatomic particle means the particles inside the atom. So he's referring to electrons, protons, and neutrons. Now, what is the charge on the electron? You should realize if we're talking about mass of an electron, it is very, very small. It is the number that he has here, or we write it as 1/1840. Now, the charge on an electron is a negative charge, so we say the electron has -1. Mass of a proton. You should realize that the mass of a proton is the same as the mass of a neutron. So neutron mass is 1, proton mass is 1. What about the charge on the neutron? You should realize that neutrons are neutral. They have no charge, so their charge is 0. Give the name of the part of the atom containing protons and neutrons. Of course, protons and neutrons are found in the nucleus. Then he has here a table showing the different species with numbers of protons, neutrons, and electrons, and he's asking some questions about it. So this is the table again. Now, the first question says, give the letter of the species that has 6 electrons in its outer shell. You should remember that when we distribute electrons, the first shell takes 2, then the next shell can take up to 8, and so on. So which of these will have 2 and then 6 in the outermost shell? That is U, because it has a total of 8 electrons. Then he says, give the mass number of Z. Well, you should know that mass number is total number of protons plus neutrons. So Z, where is Z? It has 12 protons and 13 neutrons, so the total is 25, so that's the mass number. Give the letter of the species that is positive. It's a positive ion. To be a positive ion, of course, it should have more protons than electrons. So which one is positive? That is W. W has 11 protons and 10 electrons. Give the letters of the 2 species that are isotopes of the same element. I'm going to remind you, isotopes means they have the same number of protons but different number of neutrons. So which 2 are isotopes? That is Y and Z. Both of them have 12 protons, but one of them has 12 neutrons, the other has 13 neutrons. So these are isotopes of the same element. Then this question is in almost every paper where he gives you the abundance of the isotopes and he asks you to calculate the relative atomic mass. Again, how do we do that? It is the mass number of one times its abundance, plus the mass number of the other times its abundance over the total abundance, which is 100. And then this is your answer, but this is not the final answer. He says give your answer to 1 decimal place, and this is a point which many students forget about. He needs the answer in 1 decimal place. So you have to round up correctly. Please, if I have 20.176 and I want it to 1 decimal, it's not 20.1. You have to round it up correctly. So this is actually 20.2. Some sugar is added to cold water in a beaker. After some time, all the sugar dissolves and spreads throughout the water. Name the that occurs which causes the sugar to spread throughout the water. Of course, the sugar spreads out through the water by the process of diffusion. State 2 ways to make the sugar dissolve more quickly. If you're trying to dissolve sugar in your tea, for example, what can you do to make it dissolve more quickly? Well, you can either heat it, so the sugar will dissolve faster if the solution is hot, or you stir it, for example, with a glass rod, or we could crush the sugar into smaller pieces. So any two of these would be the correct answer. Then here he says pure water can be obtained from sugar solution using this apparatus. Name the process used to obtain pure water from sugar solution. Remember, if I have a solution and I want the water, I use this process. And this process is called simple distillation. Remember, if I had the solution and I wanted the sugar, then I would be doing crystallization. And if I had a mixture of 2 liquids, then I would be doing fractional distillation. So I want the pure water. This is simple distillation. Now explain the purpose of apparatus X. Again, I'm going to remind you, X is the condenser. What is the function of the condenser? To cool and condense the vapor. Okay, then this next question is talking about paper chromatography, and he has E, F, G, and H, and he did chromatography for them. And then he's saying, describe how the student should complete the experiment after putting a spot of each food coloring on the paper. So he's telling me that he has already put spots of the food coloring on the paper. Then what? Well, he should know that then we're going to put the paper into a beaker containing a very small amount of water. Remember, we're talking about food coloring, so the solvent should be water. The water should be below the baseline. Allow the water to move up the paper until it reaches near the top. Remove the paper, allow it to dry. So these are the steps of doing paper chromatography. I'm going to remind you again, the baseline should be in pencil. And if he says, why is the baseline in pencil? I will tell him because the graphite in the pencil does not dissolve in the solvent, so it will not interfere. And you should realize, again, the water level should be below the baseline. Why is that? To avoid dissolving the spots in the solvent. Then he says, deduce the number of dyes in food coloring H. I'm going to remind you again that each of these food colorings go up and separate into different spots. So E, for example, has separated into 2 spots, and that means it has 2 constituents or 2 substances inside it. Now F remained on the baseline, G went up to form only 1 spot, and that means that G is what we call pure. It has only 1 component. H also gave only 1 spot, so it has only 1 component. So he says deduce the number of dyes in H. Well, it gave only 1 spot, and that means it has only 1 dye. Suggest why food coloring F does not move up. We said the one that does not move up is insoluble in the solvent. Remember, the components are separated in chromatography based on their solubility in the solvent. So the one that is more soluble will go up further. The one that is not soluble will remain on the baseline. So explain which two food colorings contain the dye that is likely to be the most soluble. So which of these has something that is the most soluble? Again, the ones that are the most soluble are the ones that go up furthest. So that would be E and H because the spots went up further than the others. Determine which food coloring contains a dye with RF value closest to 0.67. I'm going to remind you again, what is RF value? RF value is distance traveled by the spot over distance traveled by the solvent. So which one is about 0.67? 0.67 means it is nearer to the top. So if you look at spot G and we measure the distance traveled by G over the distance traveled by the solvent, that means the distance up to the solvent front, that upper line, that would be about 0.67, so it is G. This question is about alkanes and alkenes, and he says complete the boxes. So he has C2H6. What is the name of C2H6? First of all, you should remember anything that has two carbons, its name must start with F. Then, is this an alkane or alkene or alcohol or acid? We said if the number of hydrogens is more than twice the number of carbons by 2, then it is an alkane. So the name of this would be ethane. Now, what is the empirical formula? You remember what is empirical formula? Empirical formula is the one showing the simplest ratios. So instead of saying C2H6, I can divide through by 2, and my empirical formula would be CH3. Now, displayed formula means I draw it all out, showing all the bonds. So I want something with 2 carbons and 6 hydrogens, and this is how we draw. Okay, then he says complete the chemical equation for the complete combustion of the alkane. So here he's just asking me to balance. I'm going to review with you again. How do we balance? We count each element before the arrow and after the arrow, and we increase the one that is less. So before the arrow, I have 2 carbons. That means after the arrow, I need 2 carbons. Before the arrow, I have 6 hydrogens. That means after the arrow, I need 2 times 3 to be 6. Now we count the number of oxygens. So remember that we leave the oxygens till the end. So after the arrow, how many oxygens do I have? I have 2 times 2 is 4, plus 3. Remember the 3 in front of the water applies to everything after it. So I have 3 oxygens and 4 oxygens. That's 7 oxygens. So I cannot say 2 times something will give me 7. I will have to use a decimal. And that means if you find that you have to use a decimal, then you multiply the original one by 2 and start all over again. So that means that now before the arrow, I have 4 carbons. After the arrow, 4 carbons. Before the arrow, I have 2 times 6. After the arrow, I need 2 times 6. Now after the arrow, how many oxygens? I have 2 times 4 is 8. 8 plus 6 is 14. And that means I need 2 times 7 to balance. So this is the balanced equation. Then he says incomplete combustion occurs when the air supply is limited. Give the names of 2 products of incomplete combustion. Remember that we said if I have complete combustion, it gives carbon dioxide plus water, like that equation above. But if I have incomplete combustion, it will give carbon monoxide and water. An alkene with molecular formula C4H8 reacts with bromine to form a compound with the molecular formula C4H8Br2. Remember, C4H8, that means it is an alkene because the number of hydrogens is twice the number of carbons. So he's saying an alkene C4H8. You should realize that when alkenes react with bromine, this kind of reaction is called an addition reaction. And if he says why it is called an addition reaction, because it gives only one product. You're adding two things together to give just one product. That is called an addition reaction. Draw displayed formula for two different alkenes with the molecular formula C4H8. How do we draw two different alkenes? That means he's saying draw isomers of C4H8. You should remember that C4H8 is butene because it has 4 carbons and it's an alkene, so that is butene. And I have two types of butene depending on the position of the double bond. So this would be called 1-butene or but1-ene. The other one is when I put the double bond in the middle, and this is but2-ene or 2-butene. And remember again, each carbon cannot have more than 4 bonds. So the carbons that have the double bond will have one hydrogen less than the others because it already has a double bond with the neighboring carbon. State the term used for compounds with same molecular formula but different structures. We said this is isomers. So these two that we just drew are isomers of butene. The alkene C3H6 can be polymerized to form the polymer polypropene. Complete the equation. Again, if I'm starting with propene and I want to draw the polymer, how do we draw polymers? We said I open the double bond, make it into a single bond, put a new bond after and a new bond before, close the bracket to indicate that this unit is repeated many times, so it is repeated n times, and then whatever was bonded to each carbon, I copy it. So the first carbon on the left had 2 hydrogens. In the polymer, it will be bonded to 2 hydrogens. The carbon on the right of the double bond has 1 bond to hydrogen, 1 bond to CH3. You just copy it as it is. And remember again, how do we name the polymer? If the polymer is propene, if the monomer is propene, the polymer would be polypropene. Two ways of disposing of polymers, such as polypropene, are burying them in landfill sites, burning them to release heat energy. Discuss the environmental problems caused by these methods of disposal. We said, what are the disadvantages of using polymers? Remember, polymers are non-biodegradable since they're inert, so they accumulate in dump sites. So we have piles of polymers now everywhere on beaches or in landfill sites. Remember, landfill sites means the dump sites or the places where they're thrown away, away from the city. Now, when burned, even if we decide to burn them, we said that's not good also because they would release toxic gases. This question is about some of group 1 elements and their compounds. A teacher adds a small piece of lithium to water in a trough. Give 3 observations that are made when lithium reacts with water. Now, this kind of question comes in almost every paper, and he could be asking you about the observations when I put lithium in water, or sodium in water, or potassium in water. And I want you to remember that in group 1, which one is more reactive? The one down is more reactive than the one up. So any reaction of potassium would be more vigorous than the reaction of sodium. And the reaction of sodium is more vigorous than the reaction of lithium. So when we put lithium in water, what do we find or what do we observe? You should realize that when any of these metals are put in water, first of all, they float because Group 1 metals have low density, so they float on top of the water. And it will dart, it will move around on the surface because the bubbles of gas will keep pushing it around. The lithium also will become smaller. The piece of lithium will become smaller, but don't say it will melt because this reaction is not as exothermic as the reaction of sodium. If we were explaining for sodium, we would say sodium floats, darts, and melts because the reaction is very exothermic. But in lithium, the lithium becomes smaller. Now, you should realize that it will give hydrogen gas, and that means that I will see bubbles of gas or effervescence. Remember, bubbles of gas is the same as effervescence. So please, when he tells you 3 observations, don't say number 1, bubbles of gas. Number 2, effervescence. They're the same. That's the same point. Okay? Okay. After the reaction has finished, the teacher adds a few drops of universal indicator to the solution. You should remember that any of these metals in water will form the hydroxide. And that means the solution will become alkaline. And that means if I put universal indicator paper, it turns blue because the lithium hydroxide that is formed is alkaline or basic. Write a chemical equation for the reaction. We said lithium plus water will give lithium hydroxide plus hydrogen. Remember we said metals of group 1 or the reactive metals at the bottom of group 2, they react with cold water, and when a metal reacts with cold water, it gives the hydroxide. Any metal that is less reactive, like zinc or magnesium, it will react with steam, and the steam gives only the oxide. And then remember, you cannot leave this equation and go on to the next one before you balance it. Many students just leave it without balance. We have to balance it so that we have the same number of each element on both sides of the arrow. Then he says a student does a flame test to see if a white solid contains sodium ions. She cleans the platinum wire before using it for the flame test. Explain why the student needs to clean the platinum wire. Remember that we clean the platinum wire to remove traces of any previous ions so that they do not interfere with the color of the flame. So if he asks me to explain how do we do flame test, I would tell him dip or clean the platinum wire in concentrated hydrochloric acid, and then dip the platinum wire into the sample and then put it into the non-luminous flame of the Bunsen burner. That's how we do flame test. Okay, which of these is the color of the flame if the solid contains sodium ions? Remember, you are required to know these colors. You should know that lithium gives red. Sodium gives what? Sodium gives yellow. Potassium gives lilac. Calcium gives brick red. Copper gives blue-green. Please learn these colors for the flame test. The next question says potassium sulfate is an ionic compound. Give the formula of each ion. So if I say I want the formula of any ion, I write its symbol, and then I should decide whether it's a positive ion or a negative ion, and the number of positives and negatives are the same as its valency or its oxidation number. So potassium is in group 1. So it is a metal, it must be positive, and if you don't remember whether something is positive or negative, please remember the first one is always positive, the second one is always negative. So if I say potassium sulfate, that means the potassium is positive. It has how many positives? It has 1 because it is in group 1, valency 1. Sulfate ion is SO4 and it has 2 negatives because its valency is 2. The melting point of potassium sulfate is this. Explain why potassium sulfate has a high melting point, and he wants you to refer to structure and bonding in your answer. So, why does any ionic compound, remember that potassium sulfate, he says up there, is an ionic compound. If he say why an ionic compound has high melting point, this is because potassium sulfate has giant 3-dimensional ionic crystal lattice. So that is the structure and the bonding. It's an ionic compound, so it has ionic bonds. It is a giant 3-dimensional crystal lattice with strong attraction forces between what? Remember, we explained melting points high or low. by the kind of attraction forces that we need to break up. So if we're talking about an ionic compound, it has high melting point. Why? Strong attraction forces between positive and negative ions. Or we could say oppositely charged ions that need a lot of energy to be broken. The next question says a student investigates the reaction between magnesium and hydrochloric acid. He uses this method, so he says add 25 centimeter cubed of hydrochloric acid to a polystyrene cup, record the temperature, find the mass of a 10 centimeter strip of magnesium ribbon, add the magnesium ribbon to the acid. When all the magnesium has reacted, record the highest temperature reached. And the first thing is complete the word equation. Again, I'm reminding you, if you want word, you have to complete it in word. Don't try to write symbols. So magnesium plus hydrochloric acid, what should that give you? Metal with acid will give salt plus hydrogen. So this is magnesium chloride plus hydrogen. Then he says the thermometer shows the temperature of the acid at the start of the experiment. Complete the table by giving the temperatures to the nearest 0.1. Please pay attention. How many decimal places does he want? So here he wants 1 decimal place. So the temperature at the start is 22.4. What would be the highest temperature reached if the temperature rises 20.8? He's given me the temperature rise, and he wants you to determine what was the highest temperature. Well, of course, the highest temperature was 43.2, so that the difference would be 20.8. Then he says, show that the heat energy change for this reaction is about 2200 joules. How do we get Q? You should remember that Q is mc delta T. So let us look at what he says. If we say Q is mc delta T, what is our M? M is the mass of the solution, and we said the mass of the solution is the same as its volume. So M is the 25 from 25 centimeter cubed of the acid, times C is a constant number, 4.2, times the change in temperature that we got from the previous table, that is 20.8. So Q is something in joules. Then he says the mass of magnesium used by the student was 0.12 grams. Calculate the value of enthalpy change in kilojoules per mole of magnesium for this reaction. And of course, you should remember that delta H must include a sign. Okay, you should realize that delta H is Q over N. Delta H is Q over N. So I need the number of moles. Number of moles of magnesium is mass over molecular mass. So the mass he gives me over the molecular mass of magnesium, that is 0.005 mole. Then I can get delta H. Delta H is Q over N, so it is the Q that we got up there. But remember that what we got up there was in joules. So if he wants it in kilojoules, I have to divide by 1,000 before I put it into the equation. Divided by the number of moles that we got, we get a number 436.8. Remember, he wants a sign. How do I decide on the sign? Remember, in the question, he says that the temperature increased. We recorded the highest temperature reached. So that means that the temperature increased. When the temperature increases, that means the reaction is exothermic and delta H is a negative number. A scientist finds an unlabeled bottle on a shelf. She thinks the bottle contains a solution of ammonium sulfate. Describe tests the scientist could do to show that the solution is ammonium sulfate. That means I need a test for ammonium and a test for sulfate. What was the test for ammonium? Please review the tests before you go to the exam. The tests are very important. So what was test for ammonium? And remember, we had a test for ammonium and a test for ammonia gas. Here we're talking about the one for ammonium. So ammonium, add aqueous sodium hydroxide, warm gently. bubbles of gas are given off that turn damp red litmus paper to blue, that would indicate the presence of ammonium ions. Then I need to do the test for sulfate. What was the test for sulfate? Add dilute nitric acid and barium nitrate solution. A white precipitate would indicate the presence of sulfate. Ammonium sulfate is often used as a fertilizer. It is prepared by reacting ammonia with sulfuric acid. Name the type of reaction that occurs between ammonia and sulfuric acid. Remember, ammonia is a base plus acid to give salt. That is called neutralization reaction. Write a chemical equation for the reaction of ammonia with sulfuric acid. Remember, ammonia is NH3 plus sulfuric acid. It gives ammonium sulfate. I'm going to remind you again, ammonia is a base. It reacts with acid to give salt, but this is the only base that does not have an oxygen in it. So it's just going to give salt, not salt plus anything else. And then you need to balance. Please do not leave the reaction without balancing. I need a 2 in front of the ammonia in order to balance this equation. Draw a dot and cross diagram to show the bonding in a molecule of ammonia. You should remember, ammonia is a compound made up of nitrogen and hydrogen. Each hydrogen has 1 electron and needs 1. But the nitrogen is in group 5. It has 5 electrons in its outermost shell. That means it needs 3 to have a full outer shell, because full outer shells need 8. So we need 3 electrons. Each hydrogen can donate only 1, so we need 3 hydrogens to share 3 electrons with the nitrogen. And don't forget the rest of the 5. Nitrogen had 5 electrons in its outermost shell, so there are still 2 up there that are not used for bonding. Okay? The next question says, a student uses this apparatus to investigate the rate of reaction between marble chips and dilute hydrochloric acid. During the reaction, the mass of the contents of the flask decreases. State why the mass decreases. Remember, he's telling me that marble chips are calcium carbonate. Calcium carbonate, when it reacts with HCl, it gives carbon dioxide gas, and this gas will come out, and that is why the mass will decrease. So it is because carbon dioxide gas is formed and it escapes. Okay, then he says, I have a cotton wool at the mouth of the flask. What is the purpose of the cotton wool? Remember, we said we want the gas to escape, but we don't want to lose any solution by splashing. Anything that is giving out a gas would probably bubble over, so I want to prevent loss of solution by splashing. Explain why sulfuric acid is not a suitable acid to use in this investigation. He's trying to use what? He's using marble chips, which are calcium carbonates, with hydrochloric acid. So what if we're using calcium carbonate with sulfuric acid? Well, the problem is the salt that is formed is insoluble. So calcium sulfate is insoluble, and this will precipitate in the reaction, and it will cover the marble chips. So the reaction will stop. In the investigation, the marble chips are in excess. Explain the shape of the graph. Now, obviously, the graph shows that at the beginning, the reaction is fast, and then the rate decreases. So you should realize that the slope is steepest at the beginning. This is because the reaction is fastest. There are lots of acid particles that collide at the same time. Then the slope decreases. This is because the rate decreases as time increases. The acid particles are being used up. Remember, the marble chips are excess, so it is the acid that is being used up. So less particles in the same volume and less collisions per minute. The student repeats the experiment using the same volume of hydrochloric acid, but half the concentration. So half the concentration, first of all, means the reaction is slower, so the new graph is below the original one. And if it is half the concentration, that means it will give out half the volume of gas. That means that instead of the graph that he has that ends at 0.54, our new graph should end up at half of that, so about 0.27 something. Okay? Explain using particle collision theory how increasing the temperature affects the rate. What happens when we increase the temperature? At higher temperature, the rate is faster. This is because particles gain more kinetic energy, move faster, more collisions per minute, and we have more molecules with high energy, higher than the energy of activation, so there are more effective collisions. Remember that we said the rate of any reaction depends on the collisions that are effective, the collisions that lead to products, not just bumping into each other, and that's it. So first of all, he says explain how increasing the temperature affects the rate. So you have to remember, many students forget to say at all that when we increase the temperature, the rate is fast. And then you explain why the rate is fast. Okay. Question 10 says the diagram shows the apparatus a teacher uses to determine the formula of an oxide of lead. So he has find the mass of the reduction tube, add some of the lead oxide to the reduction tube, find the mass of the reduction tube and lead oxide, pass hydrogen gas over the lead oxide and ignite the hydrogen at the hole on the other end. Heat the lead oxide strongly for 10 minutes. Keep passing hydrogen through the reduction tube until the tube and contents are cool. Find the new mass of the reduction tube and its contents. Now, give a reason why hydrogen is passed through the reduction tube until the tube and contents are cool. I keep passing hydrogen until everything has cooled down at the end. This is to avoid having the lead that is formed reacting again with oxygen to reform lead oxide. I'm trying to change the lead oxide to lead. I don't want it to react again with oxygen in the air to return back to lead oxide. So I have to keep passing hydrogen over it until it cools down. Describe what the teacher should do next to make sure all the lead oxide has been reduced. Of course, when we do any of these reactions, what we do is we keep reheating and reweighing until the mass is constant or until we reach constant mass. The teacher completes the experiment. He has the mass of the tube, the mass of tube plus lead oxide, and mass of tube plus lead alone at the end. So what would be the mass of the lead? The mass of the lead is the difference between mass of tube plus lead and the mass of tube. So that comes out to be 4.66 grams. Then what is the mass of oxygen? Well, the mass of oxygen is the difference between the one with lead oxide and the one with just lead. So it is the difference between the tube plus lead oxide and the tube plus lead. So that gives me a mass of oxygen of 0.48. Then he says determine the empirical formula. How do we get the empirical formula? He said we write the masses of each one, divide each one by its atomic mass to get the number of moles. What comes out, I simplify, so I divide by the smallest. And that this here gives me a ratio of 1 to 1.3. Please do not round up the 1.3 to 1. 1.3 is not the same as 1. This is not 1 to 1. It's 1 to 1.3. So you have to multiply through by a number that makes the numbers whole numbers. So if you multiply the 1.3 by 3, you get 4, but you have to multiply all through by 3. So that means my ratio is, instead of 1 to 1.3, it is 3 to 4. Please do not regard it as 1 to 1. And this is the common mistake that most students do. If it comes out 1.3, you multiply through by 3, that makes it 3 to 4. And that means my empirical formula is PB3O4. And don't forget to write the empirical formula at the end. Don't stop at the ratios. He's not asking you to give me the ratios. He's asking you to give me the empirical formula, which is PB3O4. Then the last question, insoluble salt lead chloride can be prepared by reacting a solution of lead nitrate with dilute hydrochloric acid. Write the state symbols. So if he says solution of lead nitrate, that's aqueous. Acid, that's aqueous. The insoluble salt lead chloride, that's solid. And acid, nitric acid, is aqueous. Remember that all acids are aqueous. Then he says, show that the maximum mass of lead chloride can be made from 0.037 mole of hydrochloric acid is about 5 grams. So basically it's asking you to calculate what is the mass of lead chloride if I'm starting with 0.037 moles of acid. So we said, if I have the number of moles of one, I look at the equation related to get the number of moles of what he's asking for. So he's saying I have 0.037 moles of hydrochloric acid, and the equation says I have 2 HCl gives me 1 of PbCl2. That means the number of moles of lead chloride is half the number of moles of HCl, and then I can use that to get the mass. The mass is number of moles times mR, and that gives me 5.1 grams, which is the correct answer. And that's the end of this paper. I hope it was useful to you. Please study whatever you were not able to answer, and I'll see you in the next video. Thank you for watching.